Hello everyone, welcome back to our tutorial on volume and surface area of pyramids, cones and spheres. So in this example, we have a piece of paper with V, the center of the circle, has a radius of 12 cm and angle AVB is 60 degrees. The paper is folded to form a cone of base radius R cm. So you've got two parts, find the base radius of the cone and find the volume of the cone. Okay, so you can try to visualize this, or you can do a small experiment. Take out a piece of paper and draw out this shape AVB and try it for yourself. But what happened here is when we fold this paper to form a cone, okay, so let me just draw this. This is our AVB. This is A, B, and this is B here. So when you fold it to form a cone, it becomes this way. Okay, it becomes this way. Our AV and VB is basically this portion here. Let me put it in green. Okay, when we join them, they are both at this line here. So A is here, V is here, and also B and V are also here. Or maybe what I can do is, you can look at it this way. This is V as well. A is here, A to V, and then B to V is here. They are joined up. Okay, so this is where the lines AB and VB mix. This green color line. Okay, and follow this blue color line here. This part of the circumference AB, when you put it together and form a cone, it forms the circumference of your circle here, the base of our cone. That's what happens. Okay, so this is our AV and BV. So what happens when you fold into a cone? This is what you get. Okay, so basically we can safely say this length of this cone is 12 cm here. Okay, which is the radius. The radius of our original AVB becomes the slant height of our cone. Right? Something that you all need to understand the concept, be able to visualize. All right. Okay, so the base radius of the cone, in this case, let's follow in red here. The base radius of the cone is this one. Okay, this is what we're looking for, the R value. So the base radius of the cone can be obtained by finding the length of AB first. Okay, this length AB. We call it arc. Okay, maybe you all have not learned this if you're in Sec 2, but those who are in Sec 3 and above, you should be familiar. Okay, the arc AB is part of the circumference. Okay, so let's find this first. So we're going to find the length of arc AB is equals to, because the angle is 60 degrees, we only want 60 out of 360 of the full circumference times by 2 pi r. Okay, so this one becomes 1 over 6 when you reduce it to the lowest term. 1 over 6 times by 2 pi, and in this case the radius is equals to 12. Okay, so use your calculator, you will get 12.5664 centimeters. Okay, that's our length of arc AB. So now for us to find the radius of the cone, it simply means the circumference. Okay, this circumference is equals to 12.564. Okay, so we form the equation 2 pi r equals to 12.5664. So we are finding the radius. So 12.5664 divided by 2 pi. Okay, divided by 2 pi, and you will get 2.00 centimeters. This is in 3SF. Okay, you will get the radius of the cone is now 2 centimeters. Okay, So let me just recap this. What is important for us to understand is when we have this paper, this AVB, the original AVB, when you fold it into a cone, okay, the length AV and BV will meet as per what is shown in our diagram here, the second diagram with the green color line. They will meet here, okay. And then the secondly is the arc AB, which is part of the full circumference of a circle, as shown in blue. Okay, from this arc, it forms a circumference of our cone. Okay, so what we need to find is the actual arc first, the length of AB, which is done here, arc AB, which is equals to 12.5664. It is now equal to a full circumference. So full circumference of circle is 2 pi r. So basically 2 pi r equals to 12.5664. From there we can get the radius of our cone. Alright? So now let's look at part B. So part B tells us to find the volume of cone. So volume of cone is obtained by taking 1/3 times by base area times by height. Okay? Okay, so from the previous diagram, we have seen how the paper move on, is folded to become a cone, right? So for us to find the volume of cone is 1/3 times by base area times by height. In this case, we already found the radius. Okay, the radius of this cone is equals to 2.00. We need to find the height. In this case, the height is as shown in blue, in green here. This is our height, and the way to find the height is by applying Pythagoras theorem. Okay, so let me show you another diagram. Okay, so this is our cone, and then this is our radius of 2, and then the value of this, the value of our slant height here is equals to 12. Our objective is to find our height, which is in blue here. Okay, so this is height. So what you see in the triangle, which is in red and blue, is a right angle triangle. And bear in mind, when you do cone, using Pythagoras theorem is one of the concepts that you need to be able to know and apply. Okay, from there we can get our height. So let's find our height first. So it will be 2.00 square plus h square equals to 12 square. So h is basically 12 square minus 2.00 square with a square root. Okay, use our calculator, and what we get is simply 11.8322 centimeters. This is our height in 4 decimal places. Okay, so for us to find the volume of cone, okay, therefore volume of cone equals to 1/3 times by base area. Base area for the cone is a circle, so it's 5 times by 2 square times by height, which is 11.8322. Okay, using our calculator, what we get is simply 49.5626. Okay, so we need to correct this to three significant figures. It becomes 49.6 cubic centimeters. Okay, so this is the volume of our cone. Okay, so the learning point from part B is for us to find the volume of cone, we are using the formula 1/3 base area times by height. Everything is available. We have all the information except for the height of the cone. Okay, so to find the height of cone, like I said, we need to apply Pythagoras theorem. Okay, which is a square plus b square equals to c square. This is the side knowledge that you need to know in order for you to deal with problems involving cones. Okay, it goes the same for pyramids as well. Okay, so applying our Pythagoras theorem, we get a height of 11.8322. Okay, and then we use this value to find our volume of cone. All right, so that's it. This is our one of the examples involving cones. I'll see you at our next video.